Okay, this is an example of a component created in UP with a Yakindu state machine driving the component. So what I've drawn is it's a fairly simple component just to show how this will work. In the shape tray, I have two instances of this gauge. And this gauge is basically composed of inner needle window with a circle and a needle and a couple of dynamics. It's not that important how this works from the perspective of um, the demo, except that it has some dynamics, it has some plugs, it has a couple windows in there. And then I manually created two instances of this to show how the instancing works. In this, I have a needle window, for instance, gauge.needle window. I have a variable list with some instanced variables, color, needle style, and rotation. These are the things that my state machine is going to control. So in Yakindu, which is the second thing, and I'm going to hide this window so you can see the Yakindu window. This is the Yakindu state chart editor, which is an Eclipse-based editor. And so what's going on in here is you have a couple of different what they call orthogonal states. So I have an animation state, which is basically moving a needle. Um, and then I have a color state, which is basically responsible for reading looking at the value and changing the color of the needle as the value changes. Then I have a reset state, which is responsible for catching an event from the user and changing the state of the needle. So I've just created a simple state machine. And the way this works is that inside of Yakindu, I can create what's called variables that are essentially they're C variables that are tied to the UP API. So for instance, I have this value here, which I'm managing inside of the state machine. I have this color, which is basically a variable handle to that color gauge. And then I have a variable handle to the rotation and the needle style. These are the same variables that I had in the um, up model are here. Then I've got this API call called upstate component get var instance rotation. So basically what that says is if I'm working with an instance of this component, I can get named whatever the name is, I can get the value of the plug there and manipulate it. So this will, when I create an instance of the state machine, it will manipulate the appropriate value. And similarly, I can get an instance of the state machine, I can get an instance of the needle window. So basically I've created with this up internal variables and interface into the up API. I can include the up API right here. And then in my state machine, I can do things like up UM2 instance set var float. That actually becomes a call into the up API when the state machine is executed. So I can provide the complete up API wrapped in these state machines essentially. And then this Yakindu environment generates essentially C code. And so the final thing I've done is I have created scaffolding. I'm going to hide Yakindu now. I've created scaffolding in my Visual Studio environment to hook up the state machine generated code and the up API. And so that's this code here. So this code would basically be auto-generated from a template to map any given component to any given up um, API up component that you create. So in the plugin initialize, which basically takes the up model, I have created this instance gauge component, gauge 1 and gauge 2, and that call maps the state machine generated code into the component. And then I've got in my plugin tick, I just tick all instances of the components, and that fires all the state machines for the components. So then I add the generated code from Yakindu into this environment here, which is this code here. And that essentially is my class, if you want to call it that, of a state machine driven up component. And so what you see here now is the running state machine. So basically it's running just like any other up model, but the state machine is managing completely the behavior of this component. So if I click the needle window, it resets the value for that instance of the state machine. As the needle comes around into the yellow and red environment, the state machine takes over. So you can see here the output of the up model. Then if you look back in the Yakindu state machine, which I'll show here, the animation state here is moving the needle every so many milliseconds, and the color state is triggering as the needle goes around. So these states are being executed in real time as the component runs, and this state machine is a complete specification for how that component reacts to events, reacts to its inputs, and fires outputs into the up named memory system. So the overall result is a component designed in up with its behavior designed in the Yakindu environment as state machines, and the entire thing running live here. So that's the Yakindu state machine-based components. There's more that needs to be done. We'll be doing events between instances of state machines and doing state machines at multiple levels. But it's definitely a really strong start to this project of um, creating higher level components with the up system.